In this video, I'm going to talk about Graves' disease, but before I do, I want to briefly go over a healthy hypothalamus pituitary thyroid axis. Here we can see neurons within the paraventricular nucleus of the hypothalamus releasing TRH into the first capillary bed of the portal system. TRH then binds to receptors on thyrotropes in the anterior pituitary, which is then triggered to release TSH, thyroid stimulating hormone, into the second capillary bed of the portal system. TSH then flows through the blood and ultimately binds to receptors on follicular cells within the thyroid gland. In response to TSH binding to its receptor, there are a lot of different effects inside the follicular cells, namely increase in iodide import, adding of iodines to thyroglobulin within the colloid, and then, of course, making T3 and T4 still attached to this thyroglobulin molecule. TSH increases the amount of T3 and T4 that is taken into the follicular cells, cleaved from thyroglobulin, and ultimately released into the blood. Now, T3 and T4, of course, bind to target tissues and induce them to essentially increase their metabolism. And whatever the function of the cell is, the metabolism is increased, or the activity is increased. Also, T3 and T4 are going to exert negative feedback farther upstream on the anterior pituitary gland in particular, but also in the hypothalamus. And so in a healthy system, more T3 and T4 is going to essentially put the brakes farther upstream, and therefore there would be less thyroid hormone released from the thyroid gland. And in this way, metabolism is maintained at an appropriate level. Now, in Graves' disease, the hypothalamus and pituitary gland and even thyroid gland function properly. What happens in Graves' disease is that the body produces antibodies that happen to act as agonists on the thyroid hormone receptor. And so TSH, binding to the thyroid hormone receptor, induces essentially the release of T3 and T4. But here, the antibodies are not actually regulated as part of this negative feedback loop. And so there is no kind of suppression of TSH and TRH released farther upstream. And so what ultimately happens is that these follicular cells are stimulated over and over and over again, and so there's a lot more T3 and T4 that are released into the blood than there otherwise should be. And so these these hormones, of course, continue to bind to their target tissues, but there's so much more of it that they actually ramp up the metabolism of all of those cells beyond what it should otherwise be. And so we see that the tissues throughout the body are going to be burning through a lot of stored energy. And so you might see weight loss and an increase in appetite to replace that fuel that is being burnt. The cardiovascular system is an organ system that is essentially ramped up. It is increased, or the metabolism is increased, and so you see an increase in heart rate and blood pressure. Now, all of this additional activity produces a lot of heat, and so the body tries to thermoregulate, therefore bringing the temperature of the body back down, and so sweating is another common symptom of Graves' disease. Also, your skeletal muscles can be kind of ramped up as well, so they might be trembling, so too many skeletal muscle contractions, more than you would otherwise find appropriate. These two aren't as well understood, but there is a thickening of the skin in some patients, such as around the shins, and essentially bulging eyes. Okay, now, over here, we can see that as the follicular cells are producing more and more and more T3 and T4, they become larger and larger. And so a goiter, right, an enlargement of the thyroid gland and kind of a swelling around the neck, is another common symptom of Graves' disease. Okay. Now, because there is so much T3 and T4, there is going to be substantial negative feedback on the anterior pituitary gland as well as the hypothalamus. And so TRH and TSH should both be very low when there is so much T3 and T4 within the blood. And so if you do if you were to run tests to detect Graves' disease, What could you look for? Well, first of all, you could look for particularly TSH levels, but you could also look for T3 and T4. You could look for TRH as well, but generally TSH is or low TSH can be indicative of Graves' disease. You can look for the antibodies that are actually causing the problem in the first place. Okay, so you can look for these. Right? If these are present, they are acting as agonists, and therefore that is the cause of the additional T3 and T4. Also, you can label iodine and essentially look for whether this process is increased. Right? So if this is acting as an agonist, then more and more iodide is going to be taken in to actually synthesize the T3 and T4 that is being released. Okay, so essentially highlighting the thyroid for this additional iodide uptake. So what are the treatments? What are the solutions? Well, a lot of these symptoms, such as high heart rate and high blood pressure, even trembling hands to an extent, all of these processes are also regulated by beta adrenergic receptors. So if you want to, in the short term, reduce the symptoms, not the problem, but the symptoms, you can take beta blockers. So blocking antagonist beta adrenergic receptors. Certain patients can take radioactive iodine to actually kill thyroid cells. Okay, so over here, if this iodine is actually radioactive, this particular cell that is accepting it can actually die. So this will reduce the amount of T3 and T4 released because there are actually fewer cells that are producing it. And finally, you can take anti-thyroid drugs to block any number of these receptors.